Hello and welcome to Patch. So we are going to be building a CO2 sensing patch today. We are going to need a couple supplies. We'll need a scrap of fabric, an Adafruit circuit playground, some conductive thread, some normal thread, our SPG30 gas sensor. You can see that there. Some safety pins, and then also some scissors. So let's go ahead and get started by using this typical thread. This is exactly like standard thread. I think this is a synthetic fiber. It's just some I had lying around. I'm going to start off by tying this thread off just like you would any other thread onto my needle. So I'm going to select a needle. So now I'm going to thread my needle and tie off. So now that I have a knot, I'm going to choose some ports to sew my circuit playground onto my fabric. So I'm just using the ports that we're not going to be using with the conductive thread. So anything I'm not using for my circuit, I can use to just kind of attach it onto my canvas so that it's easier to work with later. So here I am, I'm coming in from the back and I'm going to sew this circuit board onto this piece of fabric just like a button. So here you can see our circuit diagram. These are the holes that we are going to be using later. So just avoid those ones, but all the other ones are fair game. So I'm just going to do this top right hand port here just to secure this board onto my fabric. So once again, this isn't anything special. I'm just going around a few times and now I'm going to tie it off on the back. So this is just to secure this circuit board onto my fabric. So to tie off, I usually just kind of impale where I've been sewing through a couple times with just like a little bit of fabric. So I just kind of pinch it up like that and then I make a loop and then I sew through the loop. And I do that once or twice to create my knot. And so usually that helps secure it a little bit better than just trying to tie it with your fingers. And this kind of technique is actually really helpful once we start using the conductive thread. Great, so I'm going to cut this off and fast forward through me securing the rest of the circuit board onto the fabric. Great, so now that these two ports are sewn on, it's pretty stable and I'm going to use my SGP30 sensor and I am going to place it next to my circuit board. So you can see all these little holes down here. Those correspond to different ports on this microcontroller. So if you remember from that circuit diagram, I'm kind of lining up where I want to place my sensor in relationship to my circuit board. So now you can see the conductive thread here. It looks like normal thread, except it's metallic. It kind of feels thick, like maybe like a coat kind of thickness thread. It's quite stiff. But you still work with it just like you would any other thread. So I'm going to cut myself off a piece of this. And then I'm going to knot it off. And I'm going to use only one strand instead of two, like I did for the normal thread. I used like a 2-ply. I tied both ends of the thread together. For this one, I'm just going to use one. So it's just going to be like a single ply thread. So there you can see my single ply knot. And now I'm going to start sewing the circuit that helps communicate data from my sensor to my circuit board. So you can see I've got SDA, SCL, ground, and then VIN. Those are the ports that we're going to be using. So I'm going to line up as best as I can. So SCL and SDA. I'm going to start with my SDA port on my gas sensor here. So I'm going to sew through it just like I would a button. So I'm going to sew through that hole and make sure the only way it's going to work is if the metal of the conductive thread makes contact with that brass on the inside of that hole. You can see that there. So that's how it's communicating data between the sensor and the circuit board. And that only works if it's constantly in contact. So while you're sewing, you really need to make sure that you are placing the thread as close as possible to that metal, so that brass lining those holes. So I'm going to go through this a few times, make sure it's nice and tight. Okay, so I've gone around that about 3 or 4 times now. Okay, so now I'm going to sew it. It's SDA on my sensor, so I need to go to SDA on my microcontroller. So here you can see me, I'm just doing like a, just like a normal, typical straight stitch from the SDA port, which I just got done going around a couple times. A straight line from that to the SDA port on my microcontroller. So I'm going to make another set of loops around that SDA connection, so that I know that that conductive thread is making contact with that metal at all times. And then I'm going to tie it off on the back exactly like I did with the other thread. So here you can see me, I'm making loops and then I'm slicing it off. Okay, so I'm going to hurry through the rest of these. I'm going to throw up the circuit diagram here on the video so that you can see, but that's my first connection. So SDA to SDA. So now I need to do SCL to SCL. I kind of have to go backwards and forwards just to make sure none of these connections cross. It's really important while you are sewing that none of your connections cross. So you can see here, this is my finished product. It looks kind of sloppy, but none of my connections are touching, except for all of these little dangly pieces of conductive thread. So my next thing I need to do is touch these up with some clear fingernail polish. So with this clear fingernail polish, and anything will work. Honestly, you could use colored nail polish as well. That's fine. I'm essentially going to use this as an adhesive, a cheap adhesive on my knots. So I'm going to take little dabs of nail polish and put them on the knots on the back of my circuit. So that's going to help them stay tied as well as we're wearing this thing around. So if you need to reference the circuit diagram, you could definitely do that. Pause the video, come back to it. It'll also be available on my website. So here I am just putting little dollops of fingernail polish onto the knots. And now I'm going to wait for about 5 minutes for that to dry. Okay, so we're back. It's been 5 minutes. I'm going to go ahead and slice up all of these extra bits of conductive thread. So if you think about these as wires, which essentially that's what they are, right? They're just like exposed wires. You don't want your electricity to cross paths, right? So if any of those little strings touch the other strings, then you'll create a short in your circuit, essentially. If you are someone who solders and does electronics regularly, you do not need to sew this circuit. You could just as easily solder your sensor onto the board. That also works just fine. I have another one right here where I've done that. But the same circuit diagram will apply, right? So you're still doing SDA to SDA, SCL to SCL, ground to ground, and then VIN to 3.5 volt. Great. Okay, so now I'm just going to finish attaching my sensor to my piece of fabric. It tends to flap around, which drives me crazy while I'm wearing them. So I'm just going to secure this to the back. And this is just typical thread. This is not conductive thread. Great. Okay, all of the sewing is done for the electronics. Now there's just sewing for fun. So now I'm just going to decorate my patch. I have a stencil because I have terrible handwriting, but you could put anything you want to on here. You could do an abstract design. I wanted a reminder as to why I'm wearing this thing in the first place. So my goal is to stop buying plastic, which I am pretty terrible at. So I am tracing these letters, and then I'll finish decorating my patch. So I'm going to embroider my letters. You could just as easily spray paint them, or, you could do just about anything you wanted to. The point of decorating it is to make it look like something that you'd wear. So go for it. Go crazy. Okay, so onward to the fun part. I'm just going to hurry and embroider this lettering onto my patch. So if you're curious about embroidery, if you've never done it before, but you're interested in learning how, obviously, as you can see, I am not the person to learn from, but YouTube is full of great tutorials on different types of stitches. As you saw from the intro of the video, a lot of people who have done this at workshops know infinitely more about embroidery than I do. So the internet is a great resource on getting started on different stitches. Here I'm just doing like a typical back stitch because it's basically the only one I know how to do. So, yeah, you can figure that out. Great. So I have embroidered my patch and it's looking pretty great. There it is. Okay, so I'm going to attach some safety pins. This way, I find it's easier to wash whatever garment I put it on, so I just put it on safety pins. So now we're going to get to coding the actual microcontroller. So the microcontroller is the Adafruit Circuit Playground Express or the Adafruit Circuit Playground. Either will work. I use this one. It's got a bunch of different features so that you can reprogram it once you're done with patch or you want to make your own project. It has this great write-up on the Adafruit website that you can take a look at. If you need to update the bootloader or you have any errors, this is a great place to figure out how to do that. There's special drivers for Windows as well, so I just wanted to point that out. So if you're using a Windows machine instead of a Mac like me, you might have to read up on that website. So the first thing that we're going to do is download the Arduino IDE. It's absolutely free. It's open source. So you can download that there. And then here on the Adafruit website, we have the setup. So we're going to install the boards that we're going to use. So we're going to use the Adafruit Circuit Playground. And I'll show you how to do that right now. So go ahead and open up Arduino once you've downloaded it or installed it. And we are going to go to Tools, Boards Manager. And in here, we're going to type in SAMD. So this is the package that includes the board that we are going to be using. It includes some other boards as well, but the one that we need is the Adafruit Circuit Playground Express. So you can see that down there. Mine is already installed. So yours will have a little button on the bottom right that says install instead of remove. But that's the one that you need. Okay, so once you've done that, you're actually going to need to close out of Arduino and open it back up. And so you need to completely close out of it, shut it down, and turn it back on. So I have done that. I'm going to copy and paste this example code called Blink from the Adafruit website. This is going to make sure that we understand how to use not only the Arduino software, but also that our board is actually functioning. So this is a great way to test it. So I'm going to save and name this file, and then I'm going to check this little check mark, and that is the compiler. That's different than this upload button. The compiler just runs through the code and makes sure it's working. The upload button actually uploads it to the board. So I'm going to go ahead and connect my micro USB to my Circuit Playground, clear off my desk, and plug it in so that we can actually upload the code. Okay, so now that you're plugged in, we're going to learn how to actually upload the code. So you can see when it's plugged in, it's got that little green light on it. So under Tools, again, Port. Now we need to select which port our Circuit Playground is actually on. You can see mine there. It's labeled Adafruit Circuit Playground. Yours might be called something else. That's fine. But now I'm going to click that Upload button, and it says Done Uploading down at the bottom. So to run the actual code that we need two different libraries. So just like we needed to include those boards, now we need to include some libraries that are going to allow us to control our lights on our board and also get data from our gas sensor. So if you go to Sketch and then include library, we can type in SGP30. So now you can see up there, Adafruit SGP30 sensor. That's the one that we need. So you can see I have mine downloaded, but it needs an update. So I'll go ahead and do that. Great. So that's the first one that we need. The second one that we need is called Adafruit NeoPixels. So I'm just going to type in NeoPixel. And you can see it's called Adafruit NeoPixels. It's down there. It's the one that I have installed already. It also needs updated, so maybe I'll do that right now. Great. Okay, so those are the two libraries that we need for our actual sketch to work. So you can find the sketch on my website. I'll also link it in the bottom of this video. So you can see it's using Adafruit NeoPixel as a library and also Adafruit SGP30 as a library, and then also Adafruit Circuit Playground as a library, which came with your board when you downloaded all of that stuff. So that's fine. Okay, so here we can see this is the actual sketch that we're going to be using. So essentially what it's doing is it's using the left and right buttons on your board and then also sensor readings from your gas sensor. So it's testing the CO2 in the air and then also testing how many volatile particles are in the air. So here I'm just going to compile it, make sure it's working. It's working, so now I'm going to upload it. So here we can see it actually uploading onto the board. All the lights usually turn red and then turn green, and then it works. So here you can see all of the data that's coming in from our sketch. So with your board plugged in, you can actually see this data. So here you can see our CO2 is around 400, which is actually pretty typical of being inside, so that's normal. Our volatile particles, our TVOC reading is about 400 or 4, which is normal. Here we get a spike, so you can see some spike of CO2. If I open up like a fingernail polish bottle, which I already did earlier, or if I breathe on it, you'll also get some spikes. And you'll be able to see the light react to that because of the sketch as well. So how I have the sketch right now is that it actually gets it changes the shade of red or green based on the CO2 readings, and then it changes its brightness based on your volatile particles. So it'll become brighter or duller depending on the air quality in the room that you were in. So you can see that data kind of real time in the lights as well. So here I'll just show you the lights in action. So once again, this is just me uploading the code. So you saw it turn red and then turn green. So now I'll show you how the patch actually works while you're wearing it. So here we can see it's kind of just like a light green. So this would be a pretty standard. So now it's getting brighter. So you can see the button function. So if I think I'm doing poorly at my goal at not buying plastic, I'll make it red. If I think I'm doing good, not buying plastic, I'll make it green so I can keep myself accountable. So red, green, everything's working. I'll wave some fingernail polish in front of it. You can see it turned a darker red. There. So all the functionality is working, so now I can attach it to some clothing. So first I need to plug in the battery so that it has some power. So I have this little battery. It plugs into the opposite side of your patch that the micro USB went in. So you can see the code still working. And now I'm going to attach it via safety pin to my vest. So you can make a little pouch on the back for your battery to sit in. So you could sew a little battery pouch onto the back of your patch, but I usually just slip mine into the pocket of my jean jacket or my vest. So here you go, all done. So now you have a CO2 sensing patch. So I hope you let me know if you've done this tutorial, what you think. If you created anything new with your own circuit playground, that would be amazing. So craft on.